This is part 2 of a Chapter 9 review, starting with question number 12. BD is the median to the triangle ABC, so these two pieces are congruent to each other. This is not an altitude because there's not right angles there, nor can it be because the hypotenuse cannot be 3 because the side is 5. But since this is the median to each other, you know that it's going to match the length of the median. So this piece ends up being 5 and 5, and now we can find BC, what we're looking for. We have 10 squared is equal to 3 squared plus x squared. This is 100 minus 9 plus x squared. Minus it over, 91 is equal to x squared. So x, which is equal to BC, is the square root of 91, and we have our answer. Number 13, rectangle ABC is inscribed in the circle. AD is 14. AB is 48. We need to find the area of the circle. Well, let's draw our diagonal in, whichever way you want to do it. You see that there's the right angle in the corner, so we can figure out the missing side. This is one of those special right triangles. It ends up being 7, 24, 25 times 2, so this piece is 50. Or you do Pythagorean theorem. That means the radius is equal to 25. The area formula for a circle is pi times radius squared. So that is 625 pi for the area. Number 14, we're missing x. This is Pythagorean theorem. So you have 3 root 7 squared is equal to 5 root 2 squared plus x squared. That's 9. 9 times 7 is 63. That's 25. 25 times 2 is 50 plus x squared. So then now this is 13 is equal to x squared. So x is equal to the square root of 13 for that answer for number 14. Number 15, you want x and y. Well, it's a 30, 60, 90 triangle. This side across from here is 2x. So we can set 2x equal to 13. So x equals 13 over 2, which ends up being the 30 side, and that is x. That means the y is the 60 side. So you plug in 13 over 2 into the x root 3 side, and you get 13 over 2 root 3, and that ends up being the y side over here. Number 6, same idea, 30 and 60. The 30 side is this side, so let's do the 90 side, which is 2x. So that's 14 root 5, because all you do is take 2 and multiply by 7 root 5. And when you want this side, you plug in a 7 root 5 into the root 3, and you get 7 root 15 for your answer. Scrolling down, we are on question 17. Question 17, the 60 side, which is the x root 3, so we said 10 equal to x root 3 divided by root 3 to get rid of it. Got to multiply top and bottom by root 3, so you get 10 root 3 over 3. That is across from the 30 side, so that's this piece over here. And if you want the other side, this side over here is multiplied by 2, so you get 20 root 3 over 3 for your answer. 18 is finally at 45, 45, 90. So across from the 45 is the x, so this is 3 root 7. And across from this side is 3 root 7 times root 2, because this is the x root 2 side. So then you get 3 roots of 14 for your answer. This side over here is still at 45, 45, 90, even though they don't have it marked. The x root 2 side is equal to 12 divided by root 2. Can't leave it down there, so you multiply top and bottom by root 2, so you get 12 root 2 over 2, which is 6 root 2 for either of these two sides, and we're done. 19, find the diagonal of the square with a perimeter of 36. Well, for question 20, if you have a square and the perimeter is 36, take 36 and divide it by 4 to give you an answer of 9. So each side is 9. You want the diagonal. Well, you know these are 45, 45, 90 triangles because it's isosceles. So this side has to be the 9 root 2 side because that's the x root 2 missing side. Otherwise, you can do Pythagorean theorem. Find the altitude and the area of the equilateral triangle with a perimeter of 36. Well, if it's an equilateral triangle, altitude is the 60 side because of the 30, 60, 90 triangle. 36 divided by 3 is 12 everywhere. That's the 2x side, so the 2x is equal to 12, so x root is 6, so the altitude is equal to 6 root 3. And then we want the area. Well, the area is base times height, half of it. So we get half of 12 times 6 root 3, and half of this ends up being 36 root 3 units squared for the area. Find the perimeter and the area of a rhombus with the diagonals of 16 and 30. Well, let's come down here. So we have a rhombus. In the rhombus, the diagonals are bisecting and perpendicular. So one is 8 and 8, and then it's 15 and 15. So this makes this piece 70 because it's an 8, 15, 17. So 17 times 4, the perimeter ends up equaling 68. And the area is the diagonal times the diagonal divided by 2. So 16 times 30 divided by 2 ends up equaling your answer of 240 units squared. The perimeter of the rhombus is 104. So another perimeter of a rhombus idea here. The perimeter is 104. So you can take 104 and divide it by 4, and you're left with 26 for each side. One diagonal length is 20, so it's 10 and 10. Alright, so this is a 5, 12, 13 multiplied by 2. So then the other diagonal, this piece is 24 and 24. So the diagonal, the second one, is 48, because that's 24 times 2. Find the area of the rhombus. Well, then you take the two rhombus diagonals is 20 times 48 and divide that by 2, and you end up with an area of 480 units squared. Number 24 and 25 are two very challenging questions. You're trying to find BC, so I'll call it Y because there's x squares in here, where there's positive values. Well, we're doing Pythagorean theorem here. So if we take x squared over 4 plus 1, and we're squaring that, we're setting equal to x squared over 4 minus 1 squared, and that's going to be plus y squared is what that is going to look like, and we're solving for y squared. Oh, we have to FOIL this piece over here, so I'm going to come off to the side and say x over 4 plus 1 times x over 4 plus 1. When I FOIL this, x over 4 times x squared over 4, it's 2x squared over 16. And we're adding an x squared over 4 and adding another x squared over 4. And then we're adding 1. So this first piece turns into the 2 and the 16 can reduce. We got x to the 4th over 8 plus 2x squared over 4 plus 1. And this side's going to equal, when I FOIL this one, I do an x squared over 4 minus 1 times x squared over 4 minus 1. You're going to get the 2x squared, 2x to the 4th over 4, over 16, and then you're going to be minusing the x squared over 4, and then we're minusing another x squared over 4, and then we're going to be adding 1. So when we look at this side, we have an x squared over 8 when we reduce it, and we're minusing 2x squared over 4, and then we're adding 1, and then we got the y squared. Well, if I bring this over to this side, these terms cancel out. I bring this over to this side, and I end up with x squared, and that equals plus 1 plus y squared. I'm looking for the y squared, so is a plus 1 over here, minus the 1 over. So I get x squared is equal to y squared. Take the square root of y, and so then the y missing piece, so BC ends up equaling x for my answer. Find the length of the hypotenuse in terms of x and y. So we'll call this z because that's what we're looking for. So when we're looking for it in terms of x and y, so we'll take the z squared, and we'll equal it to the x to the 4th plus y to the 4th, square it, plus the square root of x plus y squared. C squared stays. When I FOIL this, you get x to the fourth plus y to the fourth, and over here you get square root 2 squared, so that becomes 2x squared y squared. Well, when I get this and I rewrite it as x to the fourth plus 2x squared plus y to the fourth, I can factor this piece here, and when I factor this piece, I get x squared plus y squared and x squared plus y squared. So when I look at this, I know that the terms of x to y, x squared plus y squared is the hypotenuse that I'm looking for. Both of those two types of questions are very challenging. This ends part 2, which is page 2, numbers 12 through 25 for the chapter 9 review.